try to remember to keep recording lectures and at least possibly putting them up online somewhere. And it'll help me with attendance. That's definitely something I always forget. Any questions? Anything? Anybody? Can you guys see the screen okay? Good. Cool. No, that was. All right, so from last time, started with chapter 1, we'll try to make it somewhat professional. Take the hat off, I guess. Wearing shorts, I guess. Introduction to exercise science, chapter number 1. Neat thermogenesis. Cool. So we needed to describe the terms involved with this, the exercise and the science. The exercise portion being performance of any physical activity to condition the body to improve health, maintain fitness, means of therapy, rehabilitation, and went into the concept of physical activity. And with that, there's a term or an acronym used to describe some, I guess, somewhat common physical activities throughout the day that we might do. Move our feet, right, twiddle our thumbs, stand around pacing. It's not structured in any way, but it's kind of a specific form of physical activity. Where that line is drawn, who knows? But it's non-exercise activity thermogenesis. And the thermogenesis meaning you're just creating heat. So any type of movement, as long as you're alive, you're creating heat somehow. Then the exercise is the actual structured form of physical activity. Then sports is just simply some type of competition, structured competition. Such as some of the great sports that we have, like poker. And, I mean, it's on ESPN, so it has to be a sport. Cornhole. Anyway, move on. And the science portion of it, systematic attempt to explain observed phenomenon and the knowledge that is gained from these attempts. So going through the scientific method, you have a problem, you have a question, trying to devise some solution to solve that problem or answer that question. And physical activity and exercise, support for promoting good health. Physical inactivity can result in early morbidity and premature mortality, or disease and death, respectively. And looked at the causes of death, the major causes of death in the United States. Heart disease, cardiovascular disease being at the top, cancer, number 2, respiratory diseases, and then we got stroke and accidents, about the same. Alzheimer's disease is up there as well, and diabetes. That's a combination of type 1 and type 2 diabetes, but there is a lot of type 2 diabetes. And with type 2 diabetes, usually the individuals are obese, and they probably have some form of heart disease as well, and they may have other conditions that are exacerbating their health problems. So, the exercise science professional and their responsibilities, helping individuals understand the importance of physical activity, exercise, and promoting fitness, health. Best practices for any injuries, or injury protection, excuse me. So preventing any injuries from occurring is arguably the #1 goal. And then any recovery, rehabilitation, any therapy afterward if somebody does suffer an injury. And design, implement fitness and exercise programs. It can be cardio related or it could be strength training related, could be rehab. And, oh, there we go. We got a city up there. Sport and athletic competition can be important for culture and society. We somewhat talked about that, I guess, last time. So all age groups can participate from very, very young up until you get to, I mean, basically till the day you die, even if you're close to 100 years of age. You can participate in something. Poker, again, there you go. And successful performance is based upon the principles that are grounded within exercise science. And I mentioned last time the science portion is the big important part there. Going through systematic attempt to explain what is happening, and it needs to be fairly rigorous and publishable so that someone else can look at it and say whether or not the methods were done correctly, if there was any major flaws, in which the conclusions aren't maybe true. There may be some phenomenon that are happening that doesn't back up the conclusions. Basically, it was a terrible study, essentially. Most of those don't get published. Every once in a while, you get one to go through. So, that's just part of the peer review process that you go through for publication of literature. And then I did discuss the static stretching study, I believe, right? I think I went somewhat in link with that, with static stretching being one of those things that we assumed was a good thing, was proper warm-up in all sports, all activities, but we know now it's maybe not the best. So why is it important for exercise professionals, to get a degree, figure out some of these phenomena and some of the facts about what happens during exercise or physical activity, or I guess even at rest. Yeah. Well, we have a lot of athletes coming in to play sports in high school. This was actually the high school graph. See the increase across boys and girls and just total overall, and then the same thing in collegiate athletics. Major increase, basically double over 20 years, 30 years, 30 years. Yeah. Sorry, I still think 1990 is like 10 years ago, so it's really strange. So I think, yeah, I ended here. So exercise science is an umbrella term. Includes anything that includes physical activity, exercise, sport, athletic competition, performance. It's all going to be included in there. Basically anything in the health field, almost anything in the health field. Maybe not medicine from a hospital standpoint, but athletic trainers are actually kind of that intermediary now. Or at least that's what they're trying to do with the requirement for the master's degree in athletic training. And physical therapists are in that same boat, and occupational therapists as well. Then you got the strength coaches, or the meatheads of the group. Never mind. Anyway, moving on. I think that was the end of the review. So common characteristics, there's movement of the body and adaptations to that movement. Sometimes the adaptations take a little while, at least a couple days normally, of continuous physical activity, of that same activity. Depending upon what the adaptation is, it may take months or possibly even years. It just depends upon what it is you're trying to do. If you're trying to regulate the blood volume a little bit better and maximize your ability to sweat. It might take a few days to bring in more water to the blood, and then it will level off. If you're trying to change fiber types in certain muscles, it's probably going to take a year or so for that adaptation to occur. So, but we won't bore you with those details. That's about it. Any questions? Anything from the gallery? Nothing? It's somebody in there. Nice neon light. Yeah. Got a Twitch streamer going on. Okay. So the umbrella terminology that we have. We have a lot of different fields, and we're going to go into most of these throughout the semester. Exercise physiology, clinical exercise physiology, biomechanics, nutrition, and dietetics, psychology, athletic training and sports medicine, and motor behavior. Then from there, for each one of these, they could branch off even further if you wanted to. Because just in exercise physiology, you can have environmental exercise physiologists, you can have essentially a strength training or personal training. So exercise and health and performance for that exercise physiology, prevention and rehabilitation of injuries, diseases, on the clinical side. The biomechanics, it's somewhat clinical, and you're looking at performance as well, but also you're trying to prevent injuries by trying to come up with better form, better techniques for motions of the body, or even equipment, making the equipment safer. I would probably say, going back to that picture that I showed at the beginning, probably a little safer having a machine than for the leg press than two people sitting on either side. You're laying on the ground and you have a weight up above your body. It's yeah, probably not safe. I mean, the bench press is already dangerous enough. I can't imagine having a bar on your feet that could easily roll. Nutrition, looking at health and performance there as well, and then trying to decrease the risk for diseases. Psychology, same thing. There, you might not necessarily be trying to prevent a disease, but possibly some type of addiction, trying to prevent being addicted to certain painkillers, maybe supplements. Athletic training, sports medicine, prevention and rehab, that as well. And then motor behavior. Motor behavior and learning can start basically from the time we're born. We go the whole way until the time we die. So it's looking at our development of our motor skills and why we do what we do and how that connection between the brain and the muscles actually functions. What are the processes that we need to go through to make the motions that we go through, actual physical motions, how do we make them smooth and decrease the risk for injuries. So a lot of this is trying to decrease risk for injuries, disease, but also trying to improve health and or performance. Any questions on that? Some good stuff. What's that? Got notes on notes on notes. Kind of already went over this, but we'll reiterate it. So physical activity is the activities of daily living. And sometimes this is actually, where's my usually pen? Sometimes this is abbreviated. Come on. Actually, just right. ADLs. That actually worked a lot better using my finger. ADL, activities of daily living. So it includes all human movement. And that NEAT, that non-exercise activity thermogenesis, is under that term as well. Then the structured form of this is then the exercise. So trying to improve fitness, improve health, decrease risk for certain diseases, and increase performance. Most often you're trying to increase performance, not always with exercise. Depending upon what you define as performance. A bodybuilder, after they retire, is going to go through a certain workout routine. They're just not going to stop. Usually they just don't stop. They'll go through certain workouts to decrease their muscle mass. They'll probably also get off of certain substances as well. So it's the non-natural bodybuilders. But they'll decrease their muscle mass, which was help them with performance in their field, in their sport. Powerlifters, same thing. And then sport and athletic competition, this is just structured movement in which there's some type of competitive aspect to it. Any questions at this point? None? On that? All right, let's go over a little history. History class. So some early influences of exercise science, if you will. We have some of the Greeks and the Romans, some of the great philosophers of our time. Socrates, Plato, Aristotle, Socrates, no, Socrates, Socrates, yeah. Bill and Ted, the original. Bill and Ted's Excellent Adventure. So you have Socrates and Aristotle. Okay. So they all examined, they were really interested in the body and the form that it took during physical activity or even at rest. In fact, they've made sculptures of a lot of the old sculptures of the human body, especially during active movement. In this case, the picture of the man with the discus here. So they examined what was going on, or trying to examine what was going on in the body. They may not have had some of the advancements that we have, and there were certain periods of time back in the Middle Ages where there was somewhat of a decrease in the knowledge that was gained about the human body, because some cultures found it really bad, and actually you could be put to death for trying to dissect a cadaver. So even somebody that was dead, you could not desecrate their body, so it had to be whole when it went in the ground. But there were still some underground dissections that were going on, and people still learned about the different organs, tried to figure out what's the heart actually do? What do the lungs actually do? Where's the blood actually coming from? So they tried to figure some of this stuff out. So anatomy was kind of the first goal there. Now we kind of already knew somewhat exactly what the organs were, because, I mean, for thousands of years we were killing animals which seemed to have the same organs we did, and we were also killing each other, and we could see inside people's bodies and see that we had the same organs that animals did, and then we knew where they were. Maybe didn't know exactly what they did, but we knew that we were made up of kind of the same stuff, and the organs were important somehow, some way. So, Leonardo da Vinci during, I guess, the Renaissance period, very important as well. He was interested in the human body, physical activity, what happens during exercise or sport competition. Especially the Greeks. The Greeks were really interested in competition. That's how we got the Olympic Games. The Romans, with the gladiators, that was kind of an important time for them. As we moved along, we started to develop some technology. The biggest one would probably be the microscope. We were actually able to see cellular material and see what some of the tissues were actually made up of. See what, not only the tissues, but the organs. What were they made up of? What made them different from, what made a liver different from a heart? What made the lung different from the stomach? So with the invention of some of those technologies, we were able to look a little bit deeper inside of the body. And then we started to actually map the blood flow. And then right around I'm trying to think when it was published, 18th, 19th century, somewhere around there, we started to actually have publications into some of this. And one of the more famous ones would be Gray's Anatomy. Mapped out pretty much the entire human body, basically. Before it jumped the shark. Jokes. That was a joke online, if you're listening. Gray's Anatomy. The actual book, not the show. So, from there, too, in the 19th century, we started to look at heart rate, blood pressure, stroke volume, and cardiac output. All those are obviously related to the heart. And in fact, actually I'll try to write it up here. Oh my goodness. Sorry, that's an H. I don't know why it's off. HR times SV equals Q. Anyone ever seen this before? So I believe it was in the 19th century someone actually figured this out. So HR, what do you think HR is? Heart rate. Heart rate. Yep. About SV.
Something volume.
Yep. Stroke volume. So heart rate is just beats per minute, how fast your heart's beating. Stroke volume is the amount of blood that's ejected from the heart in one beat. If you multiply both of those numbers, you have the amount of blood volume for every beat times the amount of beats per minute. you have Q, which is, yeah, basically quantity, the amount of blood injected from the heart every minute, or otherwise known as cardiac output. So we figure out how much blood is ejected each minute. Seems like a simple equation, and you're probably thinking, okay, we know the volume, but how do we use it? This actually comes very important when trying to figure out how much oxygen someone is using during a certain physical activity. It's probably one of the most important components of it. So if you change the heart rate, you could change the cardiac output. If you change the stroke volume, you change the cardiac output. And then there's also a couple other numbers that go into stroke volume too that we're not going to go into. So any little changes are going to change how much oxygen you're utilizing during physical activity. Any questions? Heart rate times stroke volume equals cardiac output, or Q. Some recent influences. Exercise science has actually been around quite a while. Other than kind of the Greeks and the Romans and Da Vinci, they might not have called it exercise science. It really started within education. It was probably in the late 1800s, maybe early 1900s, there started to be programs in colleges for physical education. So phys ed classes started to be developed. Then from there, it branched off into a major field then, and even more specific degrees. One of the most famous programs in the field is known as the Harvard Fatigue Lab, obviously at Harvard. This lab started, I believe, in the 30s. Lasted about 20-some odd years, 25 years or so. The funding got cut and it kind of fizzled out. But some of the most groundbreaking studies were performed in this lab on nutrition, on maximal exercise, submaximal exercise, so anything that is just below your full out max, and environmental factors on the human body, certain drugs, certain other substances. From the lab, there was a lot of graduates from that program. Then they went to different colleges and then started their own programs. And they kind of branched off from there. So this was essentially the grandfather of most of the exercise science, exercise physiology, kinesiology, exercise, whatever else you want to put in there, programs throughout the country. As soon as we get to the mid-1900s, we started to have what's known as cross-Weber tests in schools. You've probably maybe done some of these, where you do a certain amount of push-ups, sit-ups, you might do pull-ups, might do standing long jumps. There were a certain set of exercises or standards that they wanted young kids to have, and that was the cross-Weber test. So they started to implement those into elementary schools mostly. And then professional organizations and associations started to be developed. American College of Sports Medicine being one of them, the National Strength and Conditioning Association, that was in the 70s, I believe. And then you started to have some other ones too. There are organizations for anatomy, biomechanics, athletic training, obviously, physical therapy, occupational therapy, motor control and learning, psychology, exercise psychology specifically. So there's a lot of different organizations now for this field. In your specific area, you can find an organization for that fits you the best. So that was kind of some of the history behind it. Questions? Anything online? So since the book is from the American College of Sports Medicine, it's one of the major organizations. Let's go over this. It started to provide a unique blend of physical education, medicine, and physiology. I described it before. It's kind of a general organization. In fact, some other organizations, when you go to their national conference, they'll actually have a booth for their own organization. So the National Strength and Conditioning Association, or the sometimes the Athletic Training Association, Physical Therapy as well, will have maybe their own booths, or at least be set up somewhere to where they can provide flyers, maybe talk about the membership, some of the benefits. With most organizations, you also have regional organizations or branches from, like American College of Sports Medicine has a Midwest, they have a Northeast. I think there's 9 or 10 different regional associations with ACSM. Texas has their own because, well, it's Texas. So, I think Alaska has their own as well. So provide significant public outreach, and most organizations, this is what they're really trying to do. They're trying to provide public outreach for delineation or dissemination of research and any of the findings within the field. Another thing too is there could be some public health initiatives that they are really trying to push. Either just trying to get the information out there and promote it, or actually going to the legislature to see if they can get funding or if they can push it through to get maybe a bill passed or whatever it may be. In fact, there's a certification in ACSM for that, where you're essentially a lobbyist for the health field. Policy. Questions? From the gallery? So, academic preparation and exercise science. Obviously, an intro to exercise science is sometimes important. One class. Anatomy and physiology is probably the backbone of it. Knowing the anatomy, what the parts of the body are, where they're located, and then also how they function. So anatomy is just basically looking at the structure of the material, of all the tissues and the organs. The physiology is describing how do each of those interact. How do they affect one another? And how does each one function on its own? Some other biological sciences just general human biology. Chemistry. Now, you don't necessarily need to be a chemistry major to work in the field. There are some areas where chemistry is definitely going to be a little bit more important, especially in research type of fields, where you're doing a lot of blood draws. You're looking at chemicals within the blood. You need to know how things react. But even then, you might not need to know the entire periodic table and all the electrons of all of the atoms. Knowing a little bit of chemistry. Along with that, biochemistry. Biochemistry is what? What do you think biochemistry is? So chemistry is the study of matter. And I always say that biochemistry is the study of things that matter. Huh? Huh? So the study of living things. No, all matter, I guess, is important. Or we wouldn't be here. Well, biochemistry is the study of basically the chemistry of living things. So a lot of times this is referring to the metabolism that is occurring within our bodies and in each of the cells of our bodies. Human development, psychology. You don't need to have a psychology degree for this unless you're wanting to go into exercise psychology, then yeah, it'd probably be a little bit important there. Some math and statistics. So that has to deal with looking at the research. If you read a peer-reviewed publication, a lot of times you'll see some stats in there. Just gives you some basis to understand exactly what analyses they use to determine what the conclusion was. And then some physics. This comes into play a lot with biomechanics. In fact, biomechanics is basically physics of the body. Well, of the body, but also there's forces outside of the body that can play a role in how our bodies react. So a little bit of understanding about physics. But again, you don't need to be Neil deGrasse Tyson to be able to be exercise scientists. Just a basic overview of, I guess, some of the steps, some of the levels you can have. Graduate study, completing a degree requirement intended for graduate program, so post-undergraduate. There are professional schools, and this is why I have this up here, the difference between a graduate program and professional schools. There's not much of a difference, but there is a subtle difference. So the professional schools make prerequisites for professionals, or for a professional program of study. Yeah, you need to have some set of classes now to get into that program. Now, all graduate programs are going to have some requirement for you to get into. But if you go into a general graduate program, those requirements are sometimes somewhat lean. So you don't have to maybe have you don't have to have 2 chemistries and 4 biologies, and you just need to basically have a degree from an accredited college and it should be good. In fact, my master's degree, my graduate degree you come into, it was basically a general exercise physiology, and there were a couple of my classmates were, I think one had a chemistry degree, but never took an exercise science class or anything. I was nutrition and went into it, so it's a little bit more of a related field, but there's been people going into general graduate program with an English degree, and then going into exercise science. So, now there's some classes you might need to catch up on once you get there, but the professional schools, physical therapy, occupational therapy, there are stringent prerequisites that you absolutely need to get into those programs. Then any certification and licensure. So you meet eligibility requirements to be able to take the exam. And then for there any employment, and that can be internship related, either paid or non-paid. And then hopefully then getting into a paid position as a full-time job from that. Some other careers in healthcare that exercise scientists can go into. Medical school. There's actually people that have gone on to become a full-fledged doctor. Awesome. I have a buddy who graduated with in grad school. He taught for a little bit, did some research, but really wanted to be in the medical field. And I believe he is an X-ray technician now. So that's kind of how he got into it. Dental school. We actually have a recent graduate who plans on going to dental school. So the base sciences are there, the basic information is there, the prerequisites are there. There might be a class or two, depending upon what you want to do. Chiropractic schools, we have, I think, 7 or 8 now that are in some form of chiropractic school from here, the graduate program. Physician assistant, and then physical and occupational therapy are really kind of the 2 big professional schools we have students try to get into. Well, I guess chiropractic schools too. I guess those are the 3 biggest ones. And personal training, strength conditioning are the other 2 big fields, big subfields in the umbrella of exercise science. So what do healthcare professionals do? Excuse me, it's Friday. So one thing you can do is you can pose for a picture and appear to be happy. That's one thing. So nursing is also another one. Any type of clinical setting, clinical being hospital setting, physical therapy clinic, chiropractic clinic. Not sure what's going on in that picture, but kind of wonder. So any type of other therapies, that's some type of foot therapy. And that would be it. Well, that's not it for what all you can do, but there's some basic pictures to sum up the chapter to end it. So that was chapter 1. Does anyone have any questions? Anyone online have any questions? No? If nothing else, on Blackboard, you should have, this should be available, this PowerPoint. I decided to put this one up. I'll probably do some skeletonized versions of future PowerPoints for the following weeks, but quiz number 1 will become available this afternoon. But week 1 stuff should be available under, I think it's weekly lectures, quizzes, assignments, I think is what the folder is. There's a drop-down menu. Week 1 should be available to you. Syllabus is up there. And there is, I did open up a discussion board. If you have any general questions, general Q&A, go ahead and ask them. I'll try to keep up at least once a day or once every other day to go and check it to see if anyone asks a question or anything. So it's general. You can ask kind of anything about the class or the material, and anyone can see it. So it'll help benefit all of us too. So, If nothing else, make sure you guys sign or check your name in the sign-in sheet. For those of you guys online, I'm going to have a sign-in sheet when you walk in on Monday. Just check your name or check it when you leave. So we'll do that for the in-person, when you are in person. Have a great weekend, guys. We'll see you.
When will that quiz be due by?
It'll probably be due, I'm going to probably say Tuesday.
Tuesday?
Yeah.
Good deal.
Tuesday or Wednesday, one of the two. Say.
Oh,